Every time an object is either stretched or compressed or bent, for example, if you are jumping on a trampoline or if you go bungee jumping, or the shock absorbers in your car or the rubber tires in the car, you would always need a pair of opposite forces acting on them to change the shape of that object. So, for example, if you have a spring and then if you hang some masses from the spring experiences a force acting on it from the weight of the mass, which is acting downwards. But then there would be a reaction force, which is in the opposite direction from the support, which then is able to extend the spring and cause an extension. So every time you need an object to change its shape, you will always have two opposite forces acting on that object. So if the force acting on the spring is causing the spring to extend, this type of force is called tensile force. And if the force acts to compress the spring or shorten it, this type of force is known as a compressive force. But again, we can see that the reaction force is acting opposite to the applied force, and this time, because the applied force is upwards, the reaction force is acting downwards. So they will always be in opposite direction to each other. The relationship between force and extension of an object can be explained using Hooke's law. So, Robert Hooke was an English polymath whose contribution spanned physics, biology, engineering, and architecture. And he's best known for Hooke's law, which describes the elasticity of materials. So, in this relationship, he explains that extension or the compression of an object is proportional to the amount of applied force on it. So, for example, if you apply a force of F on a spring and it extends by the amount of X, you would need twice the amount of the force to make it extend by 2x. And we can express this relationship using this equation F equals K times X, where F represents the force measured in newtons, X represents the extension or the compression measured in meters, and K represents the spring constant measured in newtons per meters. And this is essentially a constant which depends on the stiffness of that object, whether it's easy to extend or compress, or whether it's very hard to compress or extend. If we plot a graph of force against extension, we see this kind of a shape where we see that the first section of the graph is a straight line. And this is the section where Hooke's law is obeyed when the force and the extension is proportional, which means that when you are applying a force on the spring, that the extension will be at the same rate. So this happens up to the point indicated by P, and P represents the limit of proportionality up to which F is equal to Kx. But if we keep applying a force beyond this point, the extension is no longer proportional to the force, and up to the point which is indicated by E, where E represents the elastic limit. So the material will become permanently stretched if we keep applying a force beyond this point. But up to that point, the deformation is elastic, which means that the object is going to return to its original shape when you remove the force. So if you are applying a force on a spring and you remove that force, the spring returns to or to its original shape when we remove the force. But beyond the elastic limit, though, the deformation is going to be plastic, which means that it is not going to return to its original shape when we remove the force.